Alright, in this video we are continuing on with solving systems of linear equations in two variables in application problems or story problems. In this example, here on the left, it says Carmina counted the quarters and dimes in her wallet and found she had $2.15. She had a total of 11 coins. How many of each type of coin did she have? So, just like my other videos, we're going to start off by defining the variables. The variables are the things we don't know. I'm going to let one variable be how many quarters. So it's asking how many of each type, meaning quarters and dimes. So I'm going to let x equal the number of quarters and y equal the number of dimes. Alright, now that we know what our variables are, we can start writing our equations. The first equation is going to deal with the total number of coins that we have. So the number of dimes plus the number of quarters is going to equal the total number that we have. So x plus y has to be 11 because we only have 11 coins in our pocket or in our wallet. The next equation is going to deal with the money. So what is each thing worth? Well, a quarter is worth 25 cents. So if we take 25 cents times how many I have, that'd be how much money I have from the quarters. Plus, a dime is worth 10 cents. So if I take 10 cents times how many dimes I have, that'd be how much money I have from the dimes. If I add those two quantities together, I should end up with the total amount I have in my wallet, which is $2.15. Now that we have two equations with two unknowns, we can solve the system. Looking at this system, I can either choose to do elimination or substitution. I think substitution is easier just because it's easier to get x or y alone here than deal with elimination and decimals. So I'm going to start by subtracting y from both sides, giving me a new equation of x equals 11 minus y, because these are gone. And now that I know what x equals, I can substitute that into the other equation. I'm going to replace x with 11 minus y. Substitute that in. Everything else is going to stay the same. Now this is a linear equation with one variable, and I can solve it for y. I'm going to start by distributing here. I know that 0.25 times 11 is going to give me 2.75, and then 0.25 times negative y is just negative 0.25y, plus everything else is staying the same. And I will combine my like terms. I have a negative 0.25 plus 0.1. It's going to give me a negative 0.15y. Again, I want to get y alone, so I need to get rid of that constant. So I subtract 2.75 from both sides, trying to get the variable alone. Now this is 0. I bring down my negative 0.15y, don't lose the negative. And 2.15 minus 2.75 is going to give me a negative 0.6. Divide both sides by negative 0.15. And I end up with y equals 4. And remember, y was, if we go back up here, y was the number of dimes. So I have 4 dimes. And I also want to know the number of quarters. Well, we know x was up here X equals 11 minus Y, right? I have to have 11 coins in my wallet. So if I take the 11 total, subtract away the 4 that are dimes, I'll end up with the 7 that are quarters. And there you go. And of course, we could check this by multiplying it out and make sure we end up with the $2.15 that we were supposed to have. All right, let's look at the other two examples here on the right-hand side that you're supposed to do. So this first one up top, or I guess I should say second, is a mixture problem. We are mixing alcohol solutions to get the desired amount. So first we're going to define our variables. Let's see what's going on. You need a 60% alcohol solution on hand. You have 175 milliliters of a 55% alcohol mixture. You also have a 95% alcohol mixture. How much of the 95% mixture will you need to add to obtain the desired solution? So this one's kind of tricky. It's not like the example that I did previously. The variables are different. Again, so important to define what it is we don't know. So I have my X. I'm going to have two things that I don't know. And let's see what they are. So we need a 60% solution. So that's the end goal. And we have 175 milliliters of a 55%. So we already know how much we have in the percent of that first amount, or that first alcohol mixture. You also have a 95% alcohol mixture. It asks how much of that we need. So that's our first variable. So the number of milliliters of the 95% solution. Okay. So we're mixing this 55% solution with the 95% solution. We know how much of the 55% we have. We don't know how much of the 95% we need to mix with it. The other thing that we don't know is how much we're going to end up with, right? It doesn't say you need to end up with 200 milliliters of the 60%. We don't know, because we're starting with this 55. We're mixing in a certain amount of that 95. And then we're going to end up with, we don't know how much 60, because we don't know how much of the 95 we're putting in. So we don't know, whoops, didn't mean to zoom that. We don't know the number of milliliters of the 60% solution. So the one that we're ending with. If we don't know how much we're mixing in, we don't know how much we're going to end up with. Alright, now we've got our two variables, we can write our two equations. So the first one that I usually start off with is the total. How much of the first type I'm going to mix with how much of the second type to get the total amount of milliliters. Well, I know how much of the first type I'm going to be putting in. We're going to be putting in 175 milliliters of the 55. Plus, we don't know how much of the 95%. So that's the X variable. And that will equal, we don't know the total amount. So the variables have moved. Last time we added X plus Y and we knew the total we wanted. Now we have a certain amount that we're starting with. We don't know how much to mix to get some total amount that we also don't know what we're going to end up with. Alright, so now that I have that equation, I can deal with the percents of alcohol in each one. So it's going to be the amount times the percent. Amount times the percent will equal the total amount times the total percent. So this, the 175 milliliters was 55%. So I have the 175 and the percent of alcohol was 55% as a decimal. The X variable was associated with the 95% solution times the amount will equal, I want to end up with a 60% solution, and I don't know how much of that it's going to be. And there you go. You have two equations with two unknowns. We can solve it. We can use elimination or substitution. In this case, it's already solved for y here. Y equals 175 plus x. It's already set up for substitution. I don't need to do any work with that. So I'm going to go ahead and use substitution. Now also, I'm going to simplify in the second equation the 175 times the 0.55. So I'll do that first. Multiply these two and get 96.25 plus, I'm leaving the x alone, and I'm substituting in, instead of writing y, I'm going to write 175 plus x, because that's what y equaled. Alright, so now I have one equation with one variable. I can solve it. So the goal is to get x alone. I'm going to start by distributing, get rid of those parentheses. Just copy down the left-hand side. And 0.6 times 175 is 105. And 0.6 times x is just 0.6x. I want to get all my x's on one side, all my y's on the other. So let me get some different colors here. So let's move the constants, the numbers without the variables, to the right hand side of the equal. And let's move the x's all to the left hand side. Combining our like terms. So I moved this positive 96 by subtracting it. Did it to both sides of the equation. I moved this positive 0.6x by subtracting it. And I can look at what's left. 0.95x minus 0.6x is 0.35x positive. And 105 minus 96.25 is a positive 8.75. I divide both sides by that 0.35 to get x alone. And x equals 25 milliliters. And that's actually the only one that we need to find. It says, how much of the 95% mixture will you need? Well, I need 25 milliliters to add to that 175 to change the percent from a 55% to a 60% alcohol. You could find y, you just add them together, but it doesn't ask us how much total we'll end up with. It just says how much of that 95 do you need. Alright, one more problem here. This one is also a mixture problem, but it's dealing with money, kind of like this other one over here. So let's see what's going on. It says, the hiking club wants to sell 50 pounds of an energy snack food that will cost them only $1.80 per pound. The mixture will be made up of nuts that cost $2 per pound and raisins that cost $1.50 per pound. How much of each should they buy to obtain 50 pounds of the desired mixture? Alright, start by defining our variables. We want the number of pounds of the nuts that are going to be mixed with the number of pounds of raisins. And we want to get a total of 50 pounds. So that's the equation I'm going to start with. However many pounds of the nuts plus however many pounds of the raisins has to give me the 50 pounds that I want to end up with. Now I throw in the money. So if the nuts are $2 per pound, I multiply 2 times the number of pounds, and that'd be how much that costs for just the nuts. Plus, the raisins are $1.50 per pound. So $1.50 times the amount of, the number of pounds of raisins, that's going to be how much the raisins cost me. And I want it to end up equaling $1.80 per pound. So 1.8 per pound. And I need 50 pounds. So that's the total amount that it's going to cost me altogether. Right? So a lot of times students forget this 50 here. It's how much it costs times how many pounds plus how much it costs times how many pounds will equal the total amount per pound times how many pounds. That's how much I would pay walking out the doors. $1.80 per pound for 50 pounds. Now this is different than other problems where they give you the total, like this one here on the left. We already know that we have a total amount of money of $2.15. Over here, we don't know the total amount it would cost for those 50 pounds. We have to calculate it. Okay, so the cost times the amount, cost times the amount, total cost times total amount. Alright, now we have these two equations. We can use substitution or elimination. Again, this one just happens to be set up nicely for substitution. So if I go ahead and subtract y from both sides, that'll give me x alone. Now we'll have the equation x equals 50 minus y. I've subtracted y, and I'm left with 50 minus y. So that's what x equals. I can substitute that into my other equation down here and solve. So replacing x with 50 minus y, leaving the y alone. And then I'm going to go ahead and multiply these two things because I can. So 1.8 times 50 is going to give me 90. I have one equation with one variable. I can solve for y. Again, start with my parenthesis. I'm going to distribute. 2 times 50 is 100. 2 times a negative y is negative 2y. Whoops, this was a plus here, not an equals. Plus 1.5y equals 90. Alright, I'm going to combine my like terms on the left-hand side of the equals. Negative 2y plus 1.5y would be a negative 0.5y. I want to get y alone, so I'm going to move away my constant, meaning the piece without the y. I subtract 100 from both sides. So this is gone. I now have negative 0.5y equals 90 minus 100, which is negative 10. Divide both sides by that negative 0.5. And now y equals a positive 20. Oops, 20. And y went with the raisins. So we want 20 pounds of raisins. Pounds of raisins. That's half my answer. We also need to know how many pounds of nuts. Well, x equals 50 minus y, because I want a total of 50 pounds. So if I subtract away the 20 pounds of raisins, it tells me how many nuts I need. So x equals the 50 minus the 20 pounds of raisins will leave me with 30 pounds of nuts. And there you go. We have both. I hope this helps with your homework. Let me know if you have any questions.